Welcome to Unit 8, Lesson 4, Critical Points. The goal for the rest of this unit, Unit 8, is to use derivatives to analyze functions and sketch their graphs. Critical means important. We have a critical point when the derivative is 0 or undefined. When the derivative is 0, that means that our graph looks like this. Our graph is going horizontally at that point. So this means the derivative is 0. I sketched a graph. At this point, it's not going up, not going down. It's a critical point. When the derivative is undefined, that means that the derivative is usually plus or minus infinity. So it's vertical. For example, I'm going to sketch a line. The line is going vertically straight up at this point. If it's going vertically straight up, the tangent line is vertical, that's a critical point. Okay. Let's look at some examples. Example 1, h of x is x squared minus 6x plus 5. I take the derivative. The derivative of x squared is 2x. The derivative of negative 6x is minus 6. The derivative of plus 5 is 0. So h prime of x is 2x minus 6. I know that the critical point is 0 or undefined. Well, it's defined everywhere, so I just want equals 0. 2x minus 6 equals 0, I get x equals 3. When x equals 3, h of 3 is equal to negative 4. So we know that 3, negative 4 is a critical point of our function h of x. Example 2. F of x is equal to x cubed minus 4x squared plus 5x minus 2. The derivative of that is 3x squared minus 8x plus 5. We want to set that to equal 0. You can use a quadratic formula or factor it to find x. I attached a link to explain how to factor it if you don't remember. We get x equals 1 or 5/3. When x equals 1, f equals 0. When x equals 5/3, f equals negative around 0.148 negative. So the critical points would be x equals 1, y equals 0, and x equals 5/3, y is approximately equal to negative 0.148. Those are the critical points. Let's look at our graphs. For example 1, that's x squared minus 6x plus 5. In decimal, that's the red graph. That's a parabola. We see that with this parabola, right here, I'm clicking on the vertex. At the vertex, it's not going up, not going down. So 3, negative 4 is a critical point. For our second function, the cubic, x cubed minus 4x squared plus 5x minus 2. This is the blue graph here on decimals. At x equals 5/3, y equals negative 0.148. The graph is not going up or down. That's a critical point. At x equals 1, y equals 0, also we have a critical point because the function is not going up or down. Last example, g of x is equal to x to the 2/3 power times x minus 1. We can distribute that to get x to the 5/3 power minus x to the 2/3 power. Again, to find critical points, we want the derivative to equal 0. The derivative is 5/3 times x to the 2/3 power minus 2/3 times x to the negative 1/3 power. If I write that out, that's 5 over 3 with an x to the 2/3 on top minus 2 over 3 with an x to the 1/3 on the bottom. That means that when x is 0, the denominator, the bottom, is also 0. But when that happens, g of prime of x is undefined. So the derivative is undefined when x equals 0. Meanwhile, the derivative is equal to 0 when x equals 2 over 5. You can solve this equation to get that. Okay. So our critical points are x equals 0. When x equals 0, g of x is equal to 0. And when x is 2/5, well, if we look at the graph, here's our graph. We see that, in fact, when x equals 0, our derivative has a sharp point. That means that it is undefined. Meanwhile, at x equals 4, y equals approximately negative 0.3257, the slope is horizontal, so those are the two critical points. So the other one is 2/5 negative about 0.3257. Those are the critical points. To summarize, to review, critical points are where the slope is 0, which means horizontal, or undefined, which means vertical. We also have to make sure that f of x does exist at those points. That's it for this video.